Okay, I'd like to continue with our discussion of area and perimeter, but this time I want to focus on two parallelograms. So I have one example here. As you can see, I want to take the same approach. I want to label everything I can, so I'm going to zoom into my diagram. And I'd like to talk about, just finding some angle measures and finding the other sides. Now, just like any parallelogram or rectangle, right, the opposite sides should be the same length, right? So we can now label this side as 8 centimeters, and we can label this side as 14 centimeters. Ooh, actually, I want to come back. I want to give myself a little space here. So I'm going to come back and talk about this in a second, okay? But let's first remember that the entire length, of this base, I'm going to use this as the base, is 14 centimeters. All right, I'll come back. You'll see why I'm doing that in a second. Now, let's talk about angle measures here, right? So I know that this angle is 120 degrees, all right? And in any parallelogram, opposite angles are equal, right? We've covered that this year, but I do think it's important to go back and review that. Opposite angles are equal. Consecutive angles, right? Back-to-back angles. This angle here would be consecutive with this one, right? They're next to each other. So what I wanted you to remember was this. Let me grab a highlighter here. So if this side is parallel to this side, well, this angle and this angle were called, remember, same side interior angles? So same side interior angles were supplementary, right? So what we're going to do is we're going to take 180 minus 120, and that's going to leave us with 60 degrees. Okay? So one more time. Opposite angles are equal. Consecutive angles are supplementary. So what I'm going to do is go ahead and throw 60 degrees over here. Okay, so now I've filled in all 4 of my angles. I have all 4 of my sides. I'm ready to tackle the perimeter, right? Perimeter should be really easy in this case because our perimeters are just nice whole numbers. So let's go ahead and do that. So I'm going to say perimeter equals. Now, you could just list all 4 of them, but I should know that my perimeter is 2 8s plus 2 14s. Okay, so 2 8s will give me 16. And 2 14s will give me 28. Therefore, our perimeter is 44 centimeters. Nice and simple, very straightforward. Didn't need any special right triangles for that. But, good segue. We will, however, use special right triangles for our next step. So the formula for the area of any parallelogram is the same as a rectangle, base times height. So I need a base. Guess what? We have it. The base is 14. So the only thing we really need to go get on our own is the height. Now, where should the height be drawn? Guys, we can draw the height anywhere, from top to bottom if we wanted to, right? As long as they form right angles, right? Height should always be perpendicular to the base. Now, I don't need to draw the height multiple times, but I'm going to draw it in a specific spot. I'm going to draw my height right here. Okay, when I draw my height right here, what I'm doing is I'm creating a 30, 60, 90 on the left. Okay, I could have drawn it over here, right? And I would have had the same 30, 60, 90 triangle on the other side, but to me that kind of looks upside down. All right, I could have done it. It wouldn't have been a problem. We would get the same angles and side lengths, but I'm choosing to use this. Just a preference then. Now, what I want to do is I want to make sure that you recognize that, hey, this is a 30, 60, 90 special right triangle. Okay, so what we have is the hypotenuse. Okay, what we're going to do is we're going to go backwards to the short leg and then to the long leg to get our height. So let's go ahead. Let's write down our 30, 60, 90 rules. That's your 2x side, right? This is the x side, right? Oh, because this is going to be 30 degrees. And then there's your height, which is going to be x radical 3. All right, so let's go ahead. Let's find. Should be quick and simple. This should work out nicely, right? We're going to divide 8 by 2 and get 4. Now I'm actually going to get rid of these x's and the rules. Okay, but this is going to be 4. Now, guys, be careful. 4 goes from here to here. All right, it's a little sloppy. Let's redo that. Okay, so 4 is just the length from here to here. I don't know why, but for some reason in the past I've seen students add that to 14 and make it 18. No, that's not going to work out here, right? That length is 14. and that stays 14. The base stays 14 the whole time. I mean, if you wanted to, I guess technically you could, you know, put a 10 here, right? Because it's 14 minus 4. There's no reason to break that down because, ladies and gentlemen, the purpose of what we just did was to get the base 14 and the height, which I forgot to finish. So we're going to take 4 times radical 3, and that's going to give us the height. Okay, so with a base of 14 and a height of 4 radical 3, let me go back over here to my area. And as usual, I'm going to keep saying it, right? I'm going to write a formula first. Now, base times height. The base for us was 14. The height we determined was 4 radical 3, excuse me. And then we're going to multiply that out, and we get 4 times 14 radical 3 is 56 radical 3. Oh, we need a label. That's going to be centimeters squared. Okay, cool. So I took my time on this one because I wanted to make sure you understand where we're getting these values from. So what I'm going to do is, on the next example, I'm just going to speed it up a little bit, right? But it's the same components, same idea. All right, here we go. So what I'd like to remind you is the angle across from 135 is equal to it, and the angles that are next to or adjacent to are supplementary. 180 minus 135 is 45 degrees. Nice. So that makes this one also 45 degrees. All right, we also have a couple side lengths written here. So what I want to do is I want to draw and write equal side lengths on opposite sides. So this would also be 6 meters. This side would be 20 meters. Okay, so finding perimeter one more time is actually pretty simple here, right? Our perimeter is going to be 2 6s plus 2 20s. Okay. 2 6s are 12, 2 20s is 40, so our perimeter would be 52 meters, right? Very simple, straightforward. But now let's go calculate our area. One more time, I'm going to zoom in here. Our area formula for any parallelogram is base times height. Area equals base times height. So I want to make sure you remember something here, ladies and gentlemen, okay? Very importantly, my base is 6. I'm going to use 6 as the base of my parallelogram. That will not change. So you know what? Just so I don't forget, let's go right over here and just plug that 6 in for my base. So now, really, the formula gives you direction. It tells you, hey, we have 6 as the base. Just go get the height, and we should be good to go. Now, if I draw the height of this, okay, I just want you to notice it kind of falls outside of the parallelogram, and that's okay. I could continue to draw the rest of this, right? And I would have a 45, 45, 90 special right triangle. But what I want to show you is, sometimes we can draw the height outside of a figure. So what I'm going to do is I'm going to draw my height. I'm just going to use a dashed line. I'm going to draw my height outside of the parallelogram. But that shouldn't matter, right? That's a little sloppy. That shouldn't matter, because it's still going to help me get my height out here, right? And we should still be able to find some angle measures. Think about it. These two angles here are supplementary. They form a linear pair. So this is going to be 45 degrees, since 45 plus 135 is 180. Now, as soon as I do that, guys, hopefully you're recognizing why I did that. I have now created a 45, 45, 90 outside of my figure, but it's going to help me determine my height. All right, so let's finish this up. So we can see that this side length here is 20 meters long. That's the hypotenuse. Guys, in any 45, 45, 90, right, that's like x radical 2. This is x, this is x. So I wanted to write those rules on there to remind you that we should be dividing by radical 2 and rationalizing, right? So what we get is a height of 10 radical 2. Again, I said in a previous video that we've been covering, rationalizing denominators, so I'm just skipping that step, all right? So there it is, all right? There is the height of our parallelogram. I could have drawn it here, could have drawn it here, here, anywhere, but I chose to draw it outside. Okay, so again, base of 6, now height of 10 radical 2. Let's go ahead and find that area. Okay, so 10 radical 2 is the height. Our final area will be 60 radical 2 meters squared. All right, ladies and gentlemen, so in this video, we've taken a look at 2 parallelograms. All right, hope it helps. Thanks, everyone.